sample of 200 tablets were produced by a company in a three different shift. Okay, the information given is a weight, relative density, and a tensile strength for the 200 samples. So first, what you do is we calculate all the mean values for the all the shift. Okay, and for the all 200 samples and for the given characteristics, and these are the values we obtain. Okay, and from here we continue to calculate the mean values for the all three different shift, and we start with the morning shift. In the morning shift we found that there were 65 samples were produced out of the 200 samples. Okay, and from here we calculate the mean values of the 65 samples for the weight, relative density, and tensile strength, and these are the values they are obtained. And we also require to draw the box and viscous diagram. First we need to calculate the mean value, first quartile value, third quartile value, and the maximum value. By using this one we are able to draw the box and viscous diagram for the weight, relative density, and the tensile strength for the morning shift. Okay, and we continue the same thing for the evening shift. Okay, in evening shift we found that there were altogether 72 samples were produced out of the 200 samples, and we found the mean value for the 72 samples for the characteristic of the mean. Okay, these are the values we obtained, and we also require to draw the box and viscous diagram by using the information we obtained for the 72 samples. Okay, and this is the box and viscous diagrams it should look like. Okay, and after this we do the similar thing for the night shift. Okay, we found that there were 63 samples, and we also do the same thing. We calculate the mean value of the 63 samples, and this is we found, and we also use the information here to draw the box and viscous diagram, and this is it should look like. We draw for weight, relative density, and the tensile strength. Okay, and finally we do a small summarize. Okay, we obtain all the data and we draw in a graph diagram. This one for mean relative density. Okay, and second is for the mean weight, and finally for the tensile strength.
So for part B, the company wants us to know whether the weight follows the normal distribution or not. So in order to do that, we need to do goodness of fit test and thus define two hypotheses, H0 and H1. The H0 states that the value follows the normal distribution with the mean 350 mg and standard deviation of 14 mg, whereas H1 states that the weight does not follow the normal distribution with mean 350 mg and standard deviation of 14 mg. We will reject our H0 if our chi-square test is greater than the value of chi-square given in the statistical data booklet. So now after doing that we find the maximum and minimum values. So the maximum values turn out to be 387.76 while the minimum values turn out to be 305.27. After that we divide into three intervals: smaller than 310, larger or equal to 310 but lower than 385, and greater than 385. After that the size of interval can be calculated with the following formula: maximum minus minimum of second range divided by the number of class in second range. Thus the maximum and minimum range turn out to be 385 and 310 mg, and the number of class is 15 mg. Thus after calculation we get the size to be 5. So after plotting this we get the values following over here. Thus the range will come out like 310, between 310 and 315, 315 to 320, and so on until 385. Thus we get the following observed frequencies over here: 202 and goes on until 3. After multiplying these values with the normal distribution we get the value of EI. If the values of EI is less than 5, then what we do is we add these values with the above values in order to make it greater than 5. Thus we will get the new table over here in which our range will become less than 325, 325 to 330, 330 between 330 and 335, and goes on until greater than 375. Thus we will get the new value of EI, and thus we will also get the new value of OI. After using the following formula of OI minus EI square divided by the EI, that means that the observed frequency minus the expected frequency square divided by the expected frequency, we get the following values. After adding following values, our chi-square test result comes out to be 20.3173. Now for 0.025 significant level we get the value of 21.92 using our statistical data booklet. Thus our chi-square test value is less than the chi-square test at chi-square values at 0.025 significant level from our statistical data booklet table. So what will happen that we will accept our H0, and thus we do not have any sufficient evidence to prove that our H0 is rejected. Thus we accept the claim that the H0 that the weight follows the normal distribution with the mean 350 mg and standard deviation of 14 mg.
For part C, ANOVA is one-way analysis of variance which is used to determine whether there are any statistically significant difference between the means of two or more independent groups. These are the data of weight and shift which is taken and arranged alphabetically from the original table. There are three different shifts. One is evening, the second one is morning, and the third one is night. The three different shifts are separate into the three different columns which is located at here. After that, I use data analysis function in Excel to get a output for ANOVA. These are the output for the ANOVA. There are two different table. The one is summary table and then second one is ANOVA table. At the first table, there are five columns. The first column is group, morning, evening, and night. The second and the following group columns are count, sum, average, and variance. And the second table, the ANOVA table, there are seven columns. The first one is source of variation, which is between groups and within groups. The second and the following columns are sum of square, degrees of freedom, mean square, F calculated, p-value, and F critical. For the p-value, we get from the output is 0.351027. At here, we use the significant level value is 0.025. So, if p-value is more than the significant level value, HO will not be rejected. Furthermore, the F value we get from the output is 1.052475 and then the F critical value is 3.75883. So, F calculated value is smaller than F critical value. We can conclude that there are no significant difference between the tablet weights from the different shifts.
So for part D of the assignment, uh, according to the data, I have made three simple linear regression analysis. So in these three analysis, I set the same hypothesis and the same significant level. So the null hypothesis is the slope is equal to 0 and the alternative hypothesis is the slope is not equal to 0. So to reject the null hypothesis, the p-value or significant f must lower than the significant level I set, which is 0.025. So um, we first look at the analysis for the weight and the relative density first. So the sample correlation coefficient for this analysis is solved, and the significant f and the p-value we can get directly from the table, and this value is larger than the significant level. So we look at the next analysis first. So the next analysis is the analysis for the weight and the tensile strength. So for this analysis, the sample correlation and coefficient is also calculated, and the significant f and the p-value we use to analysis is also can get directly. So this value is also larger than the significant level. So these two analyses can be said is the next hypothesis is failed to reject, and we conclude that the data does not provide a strong evidence to support the existence of linearity between two variables for these two analysis. So the third analysis is the analysis for relative density and the tensile strength. So the sample correlation coefficient also calculated in this analysis. The significant f and the p-value in this analysis is lower than the significant level. So the null hypothesis is rejected, and we conclude that the data provide a strong evidence to support the existence of linearity between relative density and the tensile strength. So because it has a slope, so we can create a linear equation by the intercept and the slope get from test table, and this is the linear equation for the line between the relative density and tensile strength. So this is the graph of relative density line fit plot for relative density and tensile strength.